Hey everyone, welcome back to another episode of SAF Podcast. And as we said in the last one, we are coming towards the end of the exciting natural theology series, specifically focusing in on the fine-tuning argument. Now, as we have done with the previous versions, when we covered the Kalam and when we covered the moral argument, we've had the final concluding episode of the particular argument as one dedicated with a special guest. Now, we've had Dave Buggett to speak on the moral argument, and you can definitely check out our interaction with Dave in the link in the description. And it was an exciting talk to have with Dave, specifically because, as you know, we cover the natural theology series based off of Dr. William Lane Craig's book, Reasonable Faith. And in the moral argument that Dr. Craig puts forward, he puts forward a deductive approach, which is similar to the fine-tuning argument as well that we covered. But Professor Dave Buggett takes sort of an inductive approach. And so it was very interesting to cover a deductive format, but also get the perspective from the inductive approach that Professor Dave Buggett put in forward. So this time we are having someone extremely famous and special in the field of fine-tuning argument to talk to us about you guessed it, the fine-tuning argument. So Dr. Luke, it's a privilege and we welcome you to SAF Podcast.
Oh, thank you for having me.
Before we get into the crux of the podcast, let me just give you a quick overview of who Luke Barnes is. Luke is a lecturer in physics at Western Sydney University with a PhD in astronomy from the University of Cambridge. And his research specifically focuses on cosmic evolution of matter, with papers published in the field of galaxy formation and evolution and on the fine-tuning for life. But he's most famous for his book, A Fortunate Universe, Life in a Finely Tuned Cosmos, published by Cambridge University Press, and also his other book, which again he has co-authored with Professor Jaren Lewis on the Cosmic Revolutionaries Handbook with the subtitle, or How to Beat the Big Bang. Now we will definitely get into some of the book, especially we will be talking about the fine-tuning argument in its central points, some of the key objections that comes up with the fine-tuning argument. But look, let me get the first thing out from the get-go. Now, Dr. Craig's format of taking on the fine-tuning argument, like I said, is a deductive format approach. Do you have any sort of areas of disagreement or difference from how he has presented it in his book? Because I understand that you were also consulted on the animated videos that Dr. Craig and his team put out for the fine-tuning argument. So, is there any place where you would differ with Craig's formulation of the fine-tuning argument, or anything that you would add on which you think he did not necessarily cover in his presentation or anything of that sort?
So his version, just to remind people, is the explanation of the fine-tuning is either chance, necessity, or design. Premise two of them, then it's not chance or necessity, so therefore it's design. And that's a good, solid, compact version of what we're basically going on here. There's a way the universe is. How did it get to be this way? Well, is there a better explanation than it just is? And so you think, well, maybe it is just this way by chance, and the fine-tuning probabilities sort of rule that one out, unless there's a multiverse, but that's another story. Or maybe it had to be this way, but saying things have to be some way or have to be that way isn't the sort of thing that science usually comes up with. We can work out the way it is, but not the way it has to be. And so that leaves, if there's a reason for the way the universe is, that really would explain some things. So that's a perfectly good sort of framework in which to discuss the fine-tuning argument. Yeah.
Yeah. And I'm given to understand that when in one point when you were commenting on the animated video that Recent Faith had put out on the fine-tuning, in place you remarked that there is a lot more fine-tuning examples that could have been covered, but not necessarily undertaken in published work, especially by Craig or in the video itself. But I believe that your book would be a great place for someone to look into if they want to see a plethora of examples of the fine-tuning that they would see in the universe.
Yeah, there's all sorts of things that we think might, and that we calculate what would happen if these numbers had been different. And, there are some cases where, not much happens, actually. There are some strange properties of neutrinos, and neutrinos don't do much anyway. So, but, they just have to be fine-tuned to stay out of the way. But how much fine-tuning is needed is another story. But, the main ones are sort of the cosmological constant. There's a number that says how quickly our universe, how fast it's accelerating in its expansion, and that number, it's very easy to make a universe where that number's just wrong by miles. Not mathematically wrong, everything's all fine in the equations, but no two particles are close enough to interact at all. So that's the end of that.
Yeah.
And then there are interesting ones. This is probably the second best set of cases is just about the masses of the particles, the stuff that you're made of fundamentally, what their basic properties. So, I think there's a good flavour of it. I mean, it's a short little animated video, so I don't want to be too critical. Actually, an early version of that had there was an error in a very small and completely inconsequential error in one of the equations, and it turned out they got it from one of my papers. So I pointed out the error, and they went, "We got it from you," and I went, "Oh," and I looked at it, there was a problem with my paper. So a bit awkward.
Yeah, no, I mean, I can understand realizing that there's a paper that you've put out where you have an error in it with. I come from an economics background, so I've put out research papers of that sort. So yeah, it's very different from getting an article out there on the internet that you can just go and tweak. That would be close to a nightmare. Yeah,
Well, it's just a typo, but it's right there. So anyway.
Now, to our viewers, if you are unfamiliar with Dr. Craig's animated works, obviously you'll find them on the YouTube channel Dr. Craig videos, but there is a YouTube channel called Dr. Craig International. And if you go into the playlist, you will find Tamil and Malayalam versions of the animated videos. So with some of our folks, myself included, we've tried to get these English videos into Indian languages. It's a field that we need a lot more people involved with. I just do Premiere Pro editing, so I just did the basics that I could. But it's a great resource for you to use if you want to get these philosophical animated arguments shown in Tamil or Malayalam as well when you take talks or you want to cover them as well. So I'll drop the link to that in the description as well. Now, Luke, you've written a very interesting book, and I can see it over your left shoulder, The Cosmic Revolutionary. Wait, you're okay. I think you're right
the other
shoulder
one.
then. Maybe it's, yeah. That was the one.
No, that is my left shoulder. I just assumed you were. Yes, go on.
Yeah. You're down under, so things may be opposite. So, so the book is called The Cosmic Revolutionary, and the subtitle is "Or How to Beat the Big Bang." Now, at first look, it looks like something that Ken Ham or Fred Hoyle would have on their reading list: "How to Beat the Big Bang." But what is the book all about? Certainly, this is not the key point of our discussion. But what is that book about, and what drove you to come up with such a book?
So it's about a very common phenomenon, actually. As we talked about the book, we've discovered this. Everyone gets this. People tell you how to do your job. Whatever job you've got, people will be happy to tell you how to do it. And Geraint and I are theoretical astrophysicists, cosmologists, and people tell us how to do our job. So we thought, well, why not actually give them a guide? Because there's a thing you get, you're not really an astronomer until some retired engineer has sent you their theory of the universe and told you to keep it a secret because they're going to be famous. And we thought, look, there's something admirable about people thinking, I'm going to work out this whole universe thing. And so we thought what we'd try and do is lay out, here are the observations as pure as we can distill them. If you can explain all of those, then you're in the game. And here's how the Big Bang explains them. And here's some other stuff the Big Bang doesn't quite explain as well. So if you can... But the point is not to just jump straight to the mysteries and explain those. You've got to sort of buy your ticket by explaining all the other stuff that we know. But that's it's a tour of the Big Bang, basically, but framed in that sort of way.
Okay, makes sense. Anyway, we'll have the books in the description as well. But now let's turn to the key part of the video that you've been waiting about. Regarding the fine-tuning argument, Luke, the way I see it, there are two main points of disagreements. And obviously, every argument has multiple ways of being disagreed with. But concerning the fine-tuning argument, concerning especially the way that it has such a pan-dialogue agreement to it, right? It's not just Christians who ever bring up the fine-tuning of the universe. You also see atheists come up and concede to it in one way or the other, the base for us to make the case. Given that, I think there are two main areas of disagreement that comes up to it. Now, they may be interlinked with each other, or maybe they may be completely independent, but I'll leave that up to you to judge. So the first one is to say that there is no fine-tuning ever to talk about. And that sounds quite quite a stretch to say, because we have all these figures from Roger Penrose about the special low entropy condition, and the comments from Paul Davies and Sir Fred Hoyle, especially the one where he says, the common sense interpretation of the facts suggests that the super intellect has monkeyed with physics and that there are no blind forces worth speaking about in nature. So why do you think this objection keeps coming up to say that, there is no really any sort of fine tuning to even need an explanation of, we don't even need to bother about physical necessity or chance or anything, because there is no fine tuning at play. What's happening there?
I think I've given talks before to, I gave one to a group called Skeptics in the Pub. This was in New Zealand once. So there was a group of who got together who were all skeptics, and I gave basically an outline of the physics of fine tuning, and then in the middle I could say, if you want to read more about this, read the book. I've authored it with a professor at Sydney University, Garrett Lewis, who was my supervisor for my honours thesis and masters, and he's an atheist, so he agrees on all the science with me. Here's why I think it points to this way, and here's how he thinks it points that way, and there's some other things some people think. And then what was fascinating was the room really couldn't leave it alone. Like, it's funny, of course you get objections from someone coming towards me.
Yeah.
What was interesting was other people in the audience were sort of intercepting the objection and arguing back to and so the room started arguing with itself. And I think that was really fascinating. So there's this feeling that something's got to be done about fine tuning. And one of the moves is always to, you can always say there's some sort of conspiracy here. One of the great things about fine tuning is, for a lot of these arguments, or the case for the existence of God, or suppose you're trying to talk about the New Testament, there's this first layer of attack where someone can say, just Christians wrote that and they just made it all up and all this sort of stuff.
Yeah.
With fine tuning, you have at least a first pushback against that, well, actually, this is something that's there in the physics literature. A lot of people who don't think it's evidence for God, at least admit that this fine tuning thing is real and worth a hypothesis about, worth the multiverse or something. It's got to mean something. So I actually know some people in the US who work on college campuses, and they'll start a chat about God, and that conversation go in 1,000 directions. But if it tends to wander over to fine tuning, they are able to they keep a copy of the book on the table and just show it and just go, well, look, here's a Christian and an atheist, and they think that this is real. So, they're both astrophysicists. They're not just someone from a different field, and it's published by Cambridge University Press, so it's not just some weird conspiracy. So it gets past that layer, I think. It's very hard to write off in those sorts of ways, but doesn't stop people from trying.
Yeah. But is that sort of an objection to say that, again, I come back to the same point, to say that there is no fine tuning to even bother about? Is that something that is held quite strongly in academia, or do you think that's sort of like a fringe position? Has most moved on to explaining what's happening there?
It's funny because there's a little bit of, when it comes up, it's mostly out in the popular world. Certainly in scientific papers, there's an agreement about, if you change this number by this much or change it by that much, then life wouldn't turn up here. And there's ways that's been refined by better arguments, better calculations over time. And so the region of these constants where you can get life, it's fairly widely agreed on. There are some people who think, well, we should define the way we measure width so that they're not wide, and so it looks like everything's going to be fine. And I think I completely disagree with that, which is, the fact that most people don't do this is why they take it so seriously. So, it's not, the sort of wholesale rejection of it is very rare in the published work in this particular field.
Yeah. Oh, yeah, that's actually a good perspective to have on this as well, because we would come across an atheist speaker who would take that stance and would be given to think, maybe this is just Christians who are doing this case. But like I said, when we look at the work of Roger Penrose and others, and atheists as well, like your co-author, it becomes clear that it's sort of pretty much mainstream to say that there is fine tuning under play. Now, the other disagreement area would, and this may get a bit technical, so we may spend a bit of time on this, just a heads up to our audience, but we will try our best to keep it as lay as possible. Obviously, I'm not an astronomer, so Luke has got to make it as simple as possible for me to follow along. So you're also in the right. Is that we can't know the probability at play. When we're talking about the fine tuning and how many odds is there, or the fine tuning of particular constant is 1 in something something, and the probability of life or the probability of getting this universe. When we get all those numbers, the objection is that, well, we can't really know probability because we just got one sample set of the universe. Now, I take it that the John Barrow example, where he draws up a whiteboard and he says, well, you take our current universe, you make it a blue dot, and you take one of the constants, make a change to it, and you see if it is life prohibiting, make it red. If life permits, make it blue, and you do that. Eventually, you'll see, a red of life prohibiting universe, a sea of red life prohibiting universes with a few dots of blue ones. And I think that makes good sense of how we can strive at the probability part, because probability is quite fixed. It's not the way we talk about plausibility in a qualitative sense, but it has a very strong sense of mathematical rigidity to it. So I understand how people would want a specific way of computing the probability there. But to say that, there is no way we can talk about probability given the only universe that we have, does that hold water in any sense? Why are they coming up with that? Is there something more to it that we are not privy of?
There are people who think that a lot depends on what you think probabilities are. So there's a narrower sense where probabilities are just related to sort of statistical ways of summarizing data, right? So if if I've rolled a die, 10,000 times, all the data is just all of the 5, 6, 7, 1, 2, no 7, sorry, 1, 5, 6, whatever, right? And I think, okay, like I could remember those 10,000 things, or I could say, look, to a good approximation, all the sides turn up once, 1 out of 6, and that's the way I've summarized the data, and that's one approach. And if that's what you think probabilities do, if they're just statistics, really, they're just ways to describe data you already have, then we've got one universe and it's life permitting, and so the probability is 1 out of 1, and what on earth are you talking about? And even if you have a slightly bigger picture of probabilities than that, where you think, they're just ways of summarizing what's going on in this universe, or part of a model of this universe, which then summarize the data that you have. So the probabilities don't have to be directly observable. They could be this sort of thing behind the scene. But if you have that idea, then the probability of our universe, or the probability of this fundamental property of our universe, doesn't make a lot of sense. Against that, I'd say, last time I checked, and I should go through these stats again sometime, you can go to the NASA ADS database, which has all the published papers by astronomers and physicists on it. And you can search for the word Bayesian, or Bayes, in the title of published, physics and astronomy works. And last time I checked, it was almost 20,000 published papers where this word was in the title of the paper. And the whole point of that approach is that you're using probabilities to model our sort of predicament, our state of uncertainty, the way that one idea we have, one thing we know might support another thing that we want to know about. So if I see clouds in the sky, how much does that support it's going to rain in an hour, and things like that. I think that broader Bayesian approach is, first of all, the fact that it's so widely used says that we know what we're doing.
Yeah.
It's not all complete nonsense, which is what would follow if you took that hard line everywhere. And I think it says, all right, is there something surprising about the way our universe is set up, which is very important. So that's the approach that I take. I've defended that in a few sort of papers, if you want to go look those up. So one called for a reasonable little universe, if you want to find, a reasonable little question, if you want to look that one up.
So I think that's the point that I want to dwell on a bit as well, because the Bayesian probability part it's not quite popular out there, because when we're talking about probability and statistics, like you said, a very narrow approach comes to everyone's mind, and we apply probability in a very limited, narrow sense in our practical engagement. And when I say we, I mean outside the rigid theoretical physics or your line of work, right? we take probability to be very simple. We have a total population, and then we look at the sample, and then we get the probability in very simple arithmetic operations. But how does the Bayesian probability factor specifically into the fine-tuning argument? Because I also understand that Dr. Craig leans to the Bayesian probability part, and not the frequentist, as I've also seen you comment as well. When you take the position, you say also, I'm not taking a frequentist position. So I want to talk about how that plays into fine-tuning. But before that, could you give a quick rundown on what Bayesian probability and frequentist probability approach generally looks like? Maybe even talking about fine-tuning or something else as well.
So frequentist is the sort of first one I talked about, where basically probabilities are just statistical descriptions of data, and or they are sort of models where you generate the probability of data. That's crucial. You have if I have a model of this coin here and I flip it, I say heads is going to be half the time and tails is half the time, and I can use that to give the probability of any sequence of heads and tails, or any sort of 50 heads and then 50 tails, whatever it is. That's the frequentist approach, where that's the role that it takes. On a frequentist approach, you can't say something like, well, given all the evidence we have, my theory is twice as likely as your theory. But you just can't say that. That's not a description of data. That's out. A Bayesian approach, the idea of Bayesian is, I'm thinking here especially, if you want to get into the details, the work of Edwin James, Jaynes, famous textbook that he sort of posthumously published, actually. And the idea is probability is this middle ground in logic, right? So there's this proves that, and there's this proves this is, this proves this is true, and this proves this is false. In the middle, there's sort of this shows that this is less likely, this is more likely. This combination of things gives that a plausibility, where one is certainty and zero is certainly not, and we're usually somewhere in the middle. And we can use the probability laws to sort of model the way that we deal with learning new things and putting different things we know together. If A and B, or not A, or A or B, or these sorts of things. So the Bayesian approach is much more broadly applicable. There are some very interesting theorems that show that if you take a reasonable approach to putting a number on plausibility, that you should treat those numbers with the same laws that you treat probabilities, which is why we're not, we treat them that way. But yeah, it's widely used in physics and astronomy. I think one of the reasons for that is that it does let you say the probability of my theory is twice as large as your theory. We want to know not just what's the probability of the data, because we have the data. We want to know, am I right? Am I right? Am I wrong? Like, is my theory better than yours, or yours better than mine? And how are the different bits of information we have interacting with that? So that's broadly what's going on.
Yeah, now that makes sense. Now, so when we talk about the fine-tuning argument, in the way we present the fine-tuning argument, obviously we, like you said, we lean on a more Bayesian way to say it. So does that mean that we're looking at something more of an inductive approach to as an inference to the best explanation to say, or do we get to some sort of realm of getting some hardcore quant to say, well, this is the probability of getting the cosmological constant to happen, the current value by chance, or this is the probability of getting the universe to have all of these values by chance? Do we get to some sort of hardcore quants in that case, or is that completely off limits?
I think you can. So I sort of attempted something like this in the paper I just mentioned, A Reasonable Little Question. I think you've got to treat this as, I'm sort of modeling a scenario here. And the point of a model is not to be perfect. The point is to be good enough that I can sort of test it. It's a good test case. So if I have a model of this room and then a model for a little couch, I can ask, well, does the couch fit in the model couch fit in the model room? And then I can work out whether the real couch fits in the real room, right? So that's the idea. Our models aren't supposed to be perfect. They're just supposed to be good enough for the purpose you want to use them for. So we can say, look, all right, I think the big question we're trying to answer is something like, is this universe anything particularly out of the ordinary, or just does any old universe make, trees and life and planets and stars and that sort of stuff? It's just this, is this like the default package you get with a universe, or is this like some special upgrade that ours has got? And the way you can model that, right? You don't have to say anything as sort of, deep as here's the probability of the universe happening at all from, with no inputs or anything like that. You can just say, look, well, I'll give you the laws of nature and some other facts about our universe, but I won't tell you what the constants are. You just sort of pick those from the available range at random, as a way of saying, what's just any old universe like? What's the default universe look like? And if those universes end out looking a bit like ours, then great. And then fine tuning says, no, we've done the hard work, we've done that, we've changed these numbers, we've done the theoretical physics. It's not been easy, but it's been done over a couple of decades. And the answer is, no, there's really something amazing going on. This is not the standard universe. This is something that does something pretty rare and amazing. So I think within the context of helpful models of our own uncertainty, that you get that picture of, we're trying to address something that's very important. We're trying to do it with the best tools we have.
Yeah, yeah. And I want to follow up on one phrase that you said, which is a place for big contention in the fine-tuning argument dialogue. Is that when you said about, well, here are the laws, I won't tell you what the constants are, but try and figure out the default universe from this range of values that the constants can take. Some objects to it saying that, well, we don't know what range could that be. We don't know the probability of each individual value coming to that constant is well, the gravity could have been, maybe 10 times more stronger, 10 times less weaker. We don't know what's the probability of each of those strengths coming into effect. Maybe something is more probable than the other. So there's a whole lot of confusion as put forward regarding the range and the individual probability of those elements in that range. Is that a solid objection to this, or is that missing the mark or asking the wrong question?
Look, if it was a successful objection, that would be reasonable, right? So if you just say, look, these, all you've got is your own assumptions here, and if I don't buy them, then I don't buy the whole story. But I think so. I think that needs an answer. One of the things I'd say is, well, it would be very strange to treat the universe as if the way it is the way it had to be without any good reason for it. And the fact that when we go changing these numbers, nothing mathematically bad happens for a while, at least, tells us that these seem to be, for all we know, perfectly possible universes. Now, could they range over infinite ranges? I think for a lot of them, for an important subclass at least, the ones I mentioned, the cosmological constant, the masses, they actually can't. And that helps us, actually. Weird things happen in the theory of how particles works if they get negative masses. So let's keep things at 0 and above. So there's one limit. And then there's an upper limit of, okay, if I had a particle that massive, it'd become its own black hole, right? And that's the sort of thing we don't have a theory to describe at all. We would need a quantum theory of gravity to start telling us what one particle black holes would be like. No one's got a clue what's going on there. So given that, we don't really have a consistent theory, we've got problems on either limit. We've got a reasonable space that we can model our uncertainty in to see what's going on. So I think the setup is fair. It certainly, if life turned up all over this parameter space that I've marked out, the sort of region we're going to look in, but the bunch of possibilities we're looking at, if life was just everywhere, yeah, I mean, I think the atheists would be trumpeting that from the rooftop. So you can't sort of, complain about the game after you've lost it.
No, I will want to come back to the one particle black hole, especially with regards to your discussion with Sabine Hossenfelder. But before that, to our listeners, you may have been following SAFT podcast for a while now, but in June, we completed 6 years of SAFT podcast, and on the anniversary of that completion, we launched a brand new vertical at SAFT. Especially, it's called Apollo Tunes, and as the name would suggest, we're trying to bring apologetics, the arguments, the thoughts that go into it, questions that needs to be asked, and thoughts that need to be taught in the form of comics. So it's simple. We have a link in the description to the Instagram page that you can follow along and make use of the comic contents in your conversation, and also to help think along and navigate these questions. Alongside that, we also have a free ebook, 10 chapters, 2 pages each, covering the basics of apologetics, the central questions of apologetics, the resurrection, the origin of the universe, and so on and so forth. Again, absolutely for free for you, in the link in the description. Feel free to make use of it, and we hope those will be useful for you to navigate the wide field of apologetics. Now, coming back to you, Luke, you've had a discussion with Sabine Hossenfelder on the Unbelievable podcast show with Justin Riley. And when I was watching it, she brings up this point of what she calls a typical example for the fine tuning, which is a pencil balanced on its tip, right? And then she comments on it and says that, well, that doesn't translate as a good example for fine tuning, because she says we observe how a pencil normally positions itself around us. So we have a data, an observational privilege regarding how a pencil should be. And so when we talk about a pencil on its tip, we say, well, that's unlikely, and it gives us some advantage to exploring why is that the case. She says we don't have that observational privilege for the fine-tuning elements, which is specifically what we cover right now, like the only samples at universe and so on and so forth. Now, my question is regarding the approach that she takes in asking that question. Sort of like, well, I don't have an observational privilege to this, so therefore, well, I'm not going to do anything with it. Nothing much to be asked. It is what it is. Is that something that's tenable in scientific inquiry? Because when you were talking about the one particle black hole, well, my understanding is that that is going to be, in some sense, beyond an observational reach. That's going to be purely within a mathematical, theoretical field for theorists to navigate and make sense of theories and competing models or something of that sort. I could be completely wrong, and maybe you could clarify on how we would explore a question of a one particle black hole in quantum gravity. But if that's the approach that Sabine should take, saying, oh, well, we don't have observational evidence, observational privilege, so these sort of questions are off limit, does that match up with an attitude of scientific inquiry?
Yeah, so Sabina's point is really that, she's basically a frequentist, right, as we explained before. So the point of statistics is to describe the way, the data we have, or models that predict data, right? So the probability of the data, it's always of the data. She has various reasons for that. She explains these in quite a bit of detail. She's got a paper on this. I think I have it with me somewhere. There's also a book called Lost in Math, where she's explained these sorts of things. And the main point she says is, arguments based on this Bayesian thing, not just fine-tuned for God, all sorts of other arguments, where you think you can use your own ignorance and then get some probabilities out of it. She thinks have sort of failed particle physics for the last decade at least. So there's an argument from her there that this is not the approach that we should be taking to doing our science. We should just describe data as it is and just sort of leave it there. And the fact that I've said that there's an awful lot of papers out there with Bayesian in the title, and I think that's what she's trying to argue against. No, we shouldn't be taking this approach. So she doesn't just have a beef with fine tuning for life for God. It's anyone who's trying this sort of approach. She just thinks it's a bit. I don't want to put words in her mouth, but I think I understand her point. I've read the paper. We had that discussion, all that sort of stuff. But so I think what she's saying is that it's just a way of allowing. It looks mathematical. It's just a way of allowing your own biases and your own human limitations to sneak into the science and into those sort of conclusions. And there's an awful lot of talk about this sort of stuff in particle physics, because there was one particular theory that was justified. We should go searching for whether this is true using the sort of fine-tuning naturalness, they're called, arguments. And it turned out not, it's called supersymmetry, but the details don't matter. The best, particle accelerator we had didn't really find it. And is that a problem? And has that shown that we shouldn't have gone down that road at all? I think the point I want to make is, I think it is justifiable. I think what Bayesian approaches do is give you the best you can do with the information that you have. And there's no guarantees you get the right answer, but you're at least being as systematically rational as you can be. And sometimes you're going to get unlucky, right? And sometimes you're going to be justified in believing in something and it's not going to be, correct. And that's just the way things go. But I don't think that's a reason to sort of throw the whole thing away. But even then, I could almost grant that, okay, you shouldn't be doing this in science, maybe. But we're doing something which is sort of metaphysical,
Yeah.
this is the best we've got there. So if you want to have a bias that says don't do metaphysics, you're allowed to have that. Unfortunately, the statement "don't do metaphysics" is metaphysics, but you know, um,
Yeah.
I think there's a sense in which the way I defend it is this is the best we can do. This is the most rational we can try to be. And the fact that so many people, so many scientists find this approach useful in studying the universe means, I think there's a weight on my side. But and so I don't find Sabine's arguments there particularly convincing.
Yeah. Oh, and I just want to take a quick detour on one point that you said that I find quite interesting to hear about. Because my exposure to quantum mechanics or theoretical physics mostly came from watching The Big Bang Theory, the TV show, with one of the character being theoretical physicist. And I remember this funny part where the character Sheldon Cooper and Leonard are having a bit of a spar, and Leonard hits back at Sheldon's paper on string theory, and he says that I didn't have to invent 12 dimensions to make my theory work. I remember listening to that and coming from a non-science background, it's like, wow, that's a lot of assumptions, stuff that you're making up ad hoc to make your theory work. So the field of quantum mechanics is very exciting and often confusing for a non-quantum mechanics person to listen to. But you mentioned about the one particle black hole, which would be a black hole the size of an atom. Like what is that all about?
Okay, so it's a very, very rough calculation that you can do, which tells you. So when do we need to use? So if I'm designing a roller coaster, right? Newtonian physics will do just fine. That's all right.
Yeah.
When do I need to invoke these other ideas? Well, right, these other theories. Well, when I've got things that are very small, I'll need quantum mechanics. And when I've got things that are very heavy, I'll need Einstein's theory of relativity. Or if things are moving close to the speed of light, right? But so if I've got something very heavy and very small, right, then these two worlds have come together. And actually, the point is that the theory doesn't know what to do, right? And so when do they sort of collide? Well, what I can think of is for any particle with a certain mass, there's a quantum size of the particle, basically the quantum fuzziness of the particle, if you want to put it that way. That's not a great way to think about it, but there's not many great ways to think about quantum mechanics. So you can say when the size of that particle, and then I can say when's that equal to the size of a black hole with the mass of that particle? When do those two overlap? And that picks out a certain mass scale. It's actually a remarkably light mass scale. It's like 1/100th of a gram or something, which on human scales is small, but for a particle that's enormous. Your electrons are like a billionth of a billionth of a billionth of a kilogram or something. So that's it. The point is not the point. The whole point of that is that we don't know what's going to happen, right? So both of those theories should be saying, have a say about this. This should happen or that should happen, right? But we don't know how they talk to each other, so we can't know what they're supposed to tell us. It's just it's very rough, very hand wavy. We don't really think there might, be a one particle black hole. We don't know what it would do. We haven't got a theory of it. We just know that that's a point where the holes in our current theory are going to turn up and really make a difference. That I can't just ignore it and use Newton or just use ordinary quantum mechanics or just use Einstein's theory. That I really do need that quantum theory of gravity.
Oh, actually, before I move on, I want to ask a follow-up question on that as well. Do you think that the laws of logic, like when people bring up quantum mechanics, I've often seen them bring it in the context of, maybe the Kalam cosmological argument of everything that begins to exist has a cause, along that lines. Do you think the laws of logic sort of break down in the application of quantum mechanics? Like to say that, causality doesn't apply. You can't talk about general way of looking at the world at the macro scale. Obviously, there is that transition from Newtonian to quantum. But to say that the laws of logic in general don't apply the quantum mechanics, is that an apt statement to make?
I think we need to. I think most people, but just in general, quantum mechanics. There's a very good book on it by, if you want to follow this up, by Tim Maudlin. What Tim Maudlin describes is that there's something called the quantum recipe, he calls it, and that's a way of really a physical theory yet. We just have this weird incantation where we say, I've got a particle and I'm going to fire it at sort of two slits in a wall over there, and I've got a screen behind it, and what's going to happen next? And then there's this mathematical incantation that you go through of you represent the particle by the wave function, and then you solve the equation to send the wave function towards the slits, and it goes through both of them and interacts with itself, and then it ends up on the other side, and then you wave the wand again and you say, all right, now take the square modulus. It's this mathematical thing. You do something with the mathematics at the other end, and what you get at the end of that is the probability that my particle will end up in a particular place on the screen, right? The bit will light up over there. Now that's the recipe. Now what's really happening that works, right? I mean, you could think of all physical theories like this. Newton says, represent the particle by a point and then solve this equation, and then there's no probabilities that turn up, but there's this mathematical incantation there as well. What's really happening? And the point is that there's a number of different ways you could think about what's happening behind the scenes in nature, which would give you the same recipe. So for most of the 20th century and maybe into the 21st, excellent book on this by Adam Becker called What is Real? On the history of quantum mechanics. For most of it, the towering figure of Niels Bohr, this Danish physicist, sort of convinced several generations of physicists that the answer was, don't look behind the curtain. That there's nothing happening behind the scenes. You can't say what's happening behind the scenes. There is no story. There is no fact. There's no, right? You do your incantation, but there's no fact about what was going to happen. There's no fact about what the wave function really is or what's really going on. There's anything like that. It's just you don't really have nature. Nothing really exists until it's observed or something like that. This what's called the Copenhagen Interpretation, but it's really the Copenhagen, shut your mouth.
Incantation.
But the problem is there are other ways. So, for example, there is many worlds, which is a very strange idea, but it is there. And a particular one I think that we're all ignoring too much is called Bohmian mechanics.
Yeah.
There's a version of quantum mechanics where the wave is real and the particle is real, and the wave guides the particle where it wants to go. And the uncertainty is just, I don't know exactly where the particle started before it went off down there. But there was a fact about where it was, and there was a fact about where it was going to go, and there was a fact about where it turns up at the other end. But my ignorance here at the start of the experiment just transfers to ignorance over there at the end of the experiment. And it's consistent with all of quantum mechanics. It gives exactly the same predictions. It's completely consistent with all the theorems of Bell's theorem and EPR and all of that other stuff. All the stuff we say about quantum mechanics. It's consistent with all of that. And yeah, it's a little bit awkward to turn into a theory that talks to Einstein's special relativity. It's slightly awkward there, but whatever. I think we need to start saying, look, okay, if what you've said isn't consistent with Bohmian mechanics, with this pilot wave theory, then it doesn't follow from the data. right? It's not that I think that this is the best theory of quantum mechanics or anything like that. I just say, look, here's a line we can draw where are you saying something that the data means we have to say because that's just the way the world is? Or are you saying something that's just your interpretation of the way things are? And Bohemian mechanics will help us draw that line. And so, does quantum mechanics show us that the laws of logic are gone, or that there's no such thing as causality, or that the future is indeterminate, or that there's no fact about what could be happening behind the scenes of nature? Are we stuck with indeterminism and quantum uncertainty? And the answer is just no. I mean, you could interpret the data that way, right? It does make a bit of sense. There are objective collapse theories, that's a thing, right? There are truly indeterministic versions of quantum mechanics. But are they forced on me by the data? No. And so, that's the situation we're in. What's forced on me by the data? I think we can help ourselves an awful lot by thinking clearly of you said this is true of quantum mechanics, but it's not true of Bohmian mechanics, so it's not true of quantum mechanics. It's true of your interpretation. And I think that would clarify an awful lot of stuff.
Yeah, yeah, which is why when I was reading upon trying to get a grasp on what quantum mechanics interpretations are all about, I remember this again. I come back to the Big Bang Theory. For just for a clarity, I am not depending my scientific knowledge on quantum mechanics on a TV show. But what was interesting note was there's this a scene where I don't know how familiar you are with the show, but I watched it
Reasonably.
a lot. Yeah. So there's the scene there where the engineer, Howard Wolowitz, he wants to do a PhD. So he tries to go for a class with the theoretical physicist Sheldon Cooper. And Sheldon tries to stump him. So he asks him, what is the correct interpretation of quantum mechanics? And Howard, the engineer, answers by saying they're all equally valid because they all give the same measurement. And then he says, but you like the many world hypothesis, so I'll say that. And I remember thinking, well, this show is extremely atheistic. Like it tries at every opportunity to put down God, the Bible, theism, belief in God, at all opportunities. And the Copenhagen interpretation is in our dialogue with atheists on Kalam is brought up to put down the Kalam cosmological argument. And I was surprised to see this show make an open admission saying that the most brainiac character on the show, who is an avid atheist, be scripted by the writers to say that he prefers the many worlds but not the Copenhagen. So that was interesting note. And like you said, the Bohmian mechanics is coming back to the picture. I have a friend of mine who is a theoretical physicist in Germany, and when I was chatting with him on this, he said to me that he leans Copenhagen, but he said he's a Christian. He leans Copenhagen, but he said we can't rule out Bohmian mechanics. I have juniors, and a lot more people are doing their fresh research on Bohmian mechanics. It is still in the picture, and a lot more needs to be explored. So that should be a good place if you want to look into different interpretation of quantum mechanics.
Yeah.
Now, coming back to the fine-tuning bit, a key point of the fine-tuning argument, what makes the argument quite special is that the centrality of the argument is the idea of life, right? We're talking about the fine-tuning argument because we are here, and we're asking, okay, what makes us or life in general possible? And in Craig's work also, he says, well, we're not talking about life as an advanced civilization, but the very basic ability for something to take in energy, reproduce, adapt, and so on and so forth. And I noticed that there's an objection to it to say that, well, why should we factor that in? Why should we take that as a starting point to make the argument and the exploration of the values of the constants to revolve around it? Like, why should we think that we should be focusing on? Now, certainly that's a very metaphysical question to ask. It's, like you said, pretty much beyond the realms of what pure scientists would want to go about. But as a Christian who deals with this question, if you were to get that question from an atheist astronomer or an atheist colleague of yours to say, well, why should we care that much about that life part? Like, why don't we ask, maybe the focus of the universe is to permit a particular galaxy to exist in some other part of the world. Maybe that's why this is fine-tuned. What would you say as a Christian scientist? I'm just curious at your personal take.
I think there's sort of two objections here. If we can separate them, things will get a bit easier. One of them is why assume that life is special? And the answer to that is, well, it's the argument doesn't assume that it's special. All you have to assume is that it exists. That'll do. And so one of the features, I think, of a Bayesian approach is that you don't have to decide beforehand what the important bits of the evidence are. You just have this sort of machine that you stick the evidence in and turn the handle. And if you put in something completely irrelevant, you won't fool the maths, right?
Yeah.
If you do, as long
Yeah.
as you do it right. Right, you can't just throw in any old weird observation and then because you got to do the whole thing. So, on a related point, this is the sort of the second way it comes out. There's this great objection. There's a wonderful set of papers by John Hawthorne and Yov Isaacs, if people want to look them up. Fine tuning, and misapprehensions about the fine tuning argument. You'll find these online somewhere. And they have this objection, which they love to call the god of tungsten. Tungsten is one of the elements in the periodic table, and they say why, these sorts of arguments would make it more likely that there exists a god who just really loves tungsten, just like thinks tungsten's the best. And they've got what I think is absolutely the right answer to this. What they say is, look, any evidence, anything that you learn, right, will make some weird hypotheses more likely, right? That's just the way that it goes about anything, right? If I see a leaf fall down outside, that makes it more likely that there's an alien up in the tree cutting leaves off. That's just the way it works, right? I see the leaf fall, the probability of an alien in the tree chopping leaves goes up. And that makes absolutely no sense because the probability doesn't become likely. It doesn't suddenly jump from 1 in a trillion to like 90% sure. It goes from like 1 in a trillion to 1 in a bit more than a trillion. Like it's just a bit less, I suppose. But that's just the way the argument works. So the question is, what does it do to the set of hypotheses that really have a chance of explaining some stuff, right? And the fact that no one proposed the idea of the god of tungsten before you made up this example is enough for us not to take it seriously. But the fact that we've got a couple of thousand years of people taking the idea of God seriously means that that one was already in the pot, right? It's already there, and maybe your probabilities were up or down beforehand, but then we learned something new. So that would be my sort of answer. We don't have to assume specialness. We just have to sort of take into account what we already thought we knew, what ideas are sort of plausible beforehand, and the fact that some really weird, stupid ideas turn out to become more likely because we learned something is just what always happens. So, it's just not a problem.
Yeah, and if we were to apply sort of like a Bayesian probability approach to the god of tungsten question, because what is the probability that a god of tungsten exists such that he wanted tungsten to exist, given our background information of what we know about the world, as opposed to what is the probability that the Christian God exists such that he wants human life to flourish, given our background information on all that we have, like I said, thousands of millions of dialogue, the resurrection argument, all of that. And that would be a Bayesian way, like where we bring in background information to see what makes the hypothesis, or which hypothesis is now more probable than the other. And it's get applied in a very qualitative way as well, not just in a very quantitative way as well. Like you said, when we put in the form of statements as well, I think everyone does Bayesian probability in one way or the other in their daily life. It's just that we don't really call it Bayesian. Like we just do that sort of reasoning on a regular basis to make sense of what's happening around us. I think that's just the way about it is.
I think that's right.
The conversation has been extremely exciting and interesting for me to be a part of, and I really love chatting with you. Now I want to come to the last two bits. If you've got around 5 to 6 minutes to wrap up, my first question is, in your perspective, what is the strongest or the central objection to the fine-tuning argument for God?
I think the multiverse is the one that most, but back against the wall. So Geraint defends the multiverse in our book, and I think the reason for that is he'd say, look, this fine-tuning's something real, something we need to understand, something we need to do something about. But I think he would take a line that invoking God would make the problem worse. It's a bit similar to what Dawkins says in The God Delusion, if you sort of clean up the philosophy a bit and make it coherent. What he's trying to say is, look, better to just assume the world exists than to assume that something really properly strange and weird like a god is out there. I think there's a picture of God there, especially with Dawkins, where Dawkins says that God is very unlikely because God's highly complex, and I think the assumption behind that is complex things are unlikely to have come together by chance, but
Yeah.
that's not our picture of how God didn't
Yeah.
form out of the bits of God by arranging them God-ishly, right? But he'd still sort of say, "Oh yeah, whatever." Like you've still got something really weird that you're going to just throw into reality. Just have the universe, right, and then be done with it. But then you have this fine-tuning problem, and this approach would then say, "Well, then let's just do whatever we need to do in the universe to make sure that it doesn't look really unlikely," and that's what the multiverse appears to be. And I think I'm actually literally, the reason I'm up this late is in an hour it will start again. There's a multiverse conference that I'm attending online where we're sort of nutting out all these sorts of things, and it's an active area of research. And the thing I'd want to say in the context of this argument is, well, first of all, I'm contributing to this. I publish papers on this stuff. I try and take this idea seriously. But in terms of what is this universe interesting or special, or is it just sort of the default that you get? The multiverse doesn't. We had this idea of, look, I've got a way of getting a range of possible universes, and then exploring them. And the multiverse says, well, what if we just sort of changed all the rules in ways that we don't understand and can't possibly calculate? And look, it's worth exploring, but as an answer to the fine-tuning argument, I think it's almost a compliment to how good it is that that's the sort of idea that comes up against it. So I think that's the most interesting objection that needs to be dealt with.
Yeah, and to our viewers, in our last episode, we did touch upon the multiverse objection and why it's still quite speculative and nothing to be worried about. And also, as Luke covered, if the universe is fine-tuned, then shouldn't the fine-tuner have a fine-tuning? Like we covered that as well in the previous episode, for something for you to look at. Now, you said that in your book there is a defense for the multiverse, and I believe that's by your co-author Gerard Lewis, correct? Because he's an atheist, right? And I believe writing a paper or a book with your research professor who takes a diametrically opposed view to your worldview would be quite intimidating, I suppose. Because I've written papers with my professors, but we all agreed on everything, so it was quite dandy. Now, that's the last bit I want to ask about. You and your co-author, who's an atheist, who's quite smart in this field like you are, both agree on the underlying facts. But has he shared any sense of changing his mind or conceding the strength of the argument that you're making? Like, what does that look like to someone like him, especially given that he's co-authoring with you?
Yeah, it's interesting. I keep trying to sort of prod him on this. I've also seen him in interviews like this where he's talking about fine-tuning, and they always get to this point in the interview, they ask him, why haven't you convinced Luke that you're right about all of this sort of stuff, which is kind of funny. I think I've heard him say a couple of little interesting things like, you're growing up, you think that naturalism is going to explain everything, and then at some point you realize, oh, maybe it doesn't have all the answers. And that was interesting. I still think if you think God's a liability, it's not an open option. If believing in God makes things worse, then it sort of doesn't matter what evidence you've got. But I think that's just for me, that's a hangover of a God is just some person in the clouds with a beard, very simplistic picture of God. But he's remarkably more open to it than these sorts of conversations. At the end of last year in November, actually, we were both in Durham, and we were at a conference which was organised by Philip Goff, it was on panpsychism, which is a very strange picture of the way that consciousness works, where everything is conscious. And he likes to talk about fine-tuning, so we were there because I was in the neighbourhood anyway. So, and so I would turn up to a conference like that, but the fact that Geraint did was sort of interesting, even though it was a very bizarre mix of ideas there. He's always been suspicious of philosophy, which is why it's not just theology, it's a wider suspicion. But one of the things that's interesting which I've been noticing. Actually, he's talking at this conference as well. He's noticing that there are some astronomers, some scientists who just don't ask these bigger questions ever. Yeah, it's just strange. I had a sort of debate that was really a discussion. I know the guy anyway, Richard Easter, who's in New Zealand, who was one of the organisers of this conference again. And we said chat about fine tuning, and at one point Richard said, one of the reasons why I'm here is we cosmologists think that we ask the big questions, but actually we kind of don't. We try to keep to really small, scientifically answerable questions, and this, like Luke's asking the big, this is asking the big questions. So that was him sort of, let's try and, he ended up defending the multiverse the way Geraint did, but I thought that was very interesting. So I hope things are breaking through in some sense. I'll keep working on it.
Yeah, and good for you for that. Well, thank you, Luke, for coming on. This has been a very interesting conversation, and I hope this brings a lot of clarity to some questions that our viewers may have had, and also probably giving you some more insights on where to take the objections you would receive, maybe on probability, and so on and so forth, to the next stage on what to explore. At least I believe with quantum mechanics, you may be hearing Bohrmian mechanics for the first time. So do check out Bohrmian mechanics and explore and enlarge your inquisitiveness. Once again, thank you, Luke, for coming on. I hope you had a splendid time, and it was a pleasure to have you on.
Thank you very much.
All right, Luke, and take care, everyone. We will see you in the next episode, which is the 100th episode of SAF Podcast, and we're working on something really special. So we'll catch you in the next one. Take care, and God bless.